Let's consider a scenario with three different outcomes. So consider a scenario with three different outcomes. For such a scenario, we could define the following forms for the probabilities. Such that probability 1 is just the number of different outcomes that involve outcome 1 over n, which we'll say is just the total number of outcomes. Similarly, P2 would be n2 over n, P3 would be n3 over n. Now, for such a scenario, we could apply different rules that depend on the characteristics of each of the different outcomes. Right? And so one of the rules that we could apply would be the addition rule. This rule applies if each of the three outcomes are mutually exclusive. So if outcome 1 occurs, if it's mutually exclusive, that would mean outcome 2 and 3 would not occur, and vice versa. All right? And so if these three different outcomes are mutually exclusive, right, we could say that the probability that either outcome 1 or outcome 2 or outcome 3 occur would just be equal to the sum of the probabilities of outcomes 1, 2, and 3. And so if we add those probabilities together, we would get the following equation. Right? And because outcomes 1, 2, and 3 are the only outcomes in this scenario, this sum would also be equal to n. Right? And so if we say that we're looking at the probability that either 1, 2, or 3 occurs, and those are the only possible outcomes in this scenario, then the overall probability here would just be equal to 1. We could also define probabilities for cases where we're only looking at 1 or 2, so that would just be equal to P1 plus P2. Or we could also look at cases for 1 or 3, so that would be equal to P1 plus P3. And then we could also look at the probability of 2 or 3 occurring. So that would be this sum here. Okay? All right, and so the addition rule applies for situations in which the outcomes are mutually exclusive. Another rule that we could apply is the multiplication rule. Okay. All right, and so this rule applies if the three different outcomes are independent. Okay? And so here, if we wanted to calculate, so in the previous one, for the addition rule, we were looking for cases where we were looking at OR. Here, we're going to look at cases where outcome 1 and 2 and 3 occur. Right? And so here, in order to calculate this probability, we would take the product of the three individual probabilities. And so here, if we do that, we would end up with this equation. Okay? In the numerator, we have the product of the number of outcomes for outcome 1, 2, and 3 all multiplied by one another. And in the previous video, or at least a shorthand we could use to describe this situation would be this, where we're just taking the product of each of these different things. In the previous video, we gave this sort of product a special name. We called it the multiplicity, and it was abbreviated as omega. Okay? Alright, so to find the probability that all three of our different outcomes occur at the same time, if these probabilities or outcomes are all independent, then we could calculate the overall probability using this equation here. Okay? Now, here, we were kind of looking at the probabilities of single-step processes. But we could also consider the probabilities of multi-step processes as well. So we would call these composite events. Okay? And so for a composite event, this will be a multi-step process that can be a mixture of mutually exclusive events. Alright, and so to give you an example of this, let's consider the rolling of a die. Right? And we'll just think of a typical six-sided die. Alright? And what we want to calculate is the probability that when we roll the die, that we get a 1 on our first roll, or a 4 on the second roll. Right? And so the key word here is we're looking at a or. Right? Okay, and so we have this multi-step process where we're looking at the probabilities. We have two different rolls, and we want to calculate the probability that we either get a 1 on the first roll or a 4 on our second roll. Right? So we have multiple steps in this process. And so to calculate the probability that's asked for, what we need to do is we need to break down our process into single-step elementary events. We need to break process into single-step elementary events. Okay? Alright, and so the way we could think of it is like this. So the probability we want to calculate is whether we get a 1 on our first roll or a 4 on our second. Okay? Alright, and so in order to calculate this, we need to, because we're dealing with an or here, we need to apply the addition rule, right? And so we're going to break our process up into different sort of events that are occurring, right? And so we need to consider all the different events that would satisfy this sort of logical relationship, okay? And so the first sort of event that we can consider, which we'll call PA, is the case where we roll a 1 on our first roll, but on our second roll we do not get a 4, right? So we need to consider the case where we get a 1 first and not a 4 second. Alright? The other sort of outcome that would satisfy this relationship would be that in our first roll we do not get a 1, and on our second roll we get a 4. Right? That would still satisfy that relationship. And then the third thing we need to consider is the case where we do get a 1 on our first roll, and we also get a 4 on our second roll. Okay. All right, and so these are the different things that could satisfy this sort of relationship here, right? And so we broke it up into kind of 3 different possibilities. And so what we need to do now, we're using the addition rule here, is now we need to calculate these individual probabilities. And so for PA, what we're looking at is the case where we get a 1 on our first roll and not a 4 on the second roll. And so here, we're looking at the case where we have 2 events occurring, right? And the value of the first roll doesn't affect the value of the second roll, right? And vice versa. And so that means these are 2 independent events. And so to calculate our PA, what we need to do is we need to calculate the probability of rolling a 1 on our first roll, calculate the probability of not getting a 4 on our second roll, and we would multiply those 2 probabilities. And so for the probability of getting a 1 on our first roll, there are 6 faces on the die, and 1 takes up one of those faces. So there's a 1 in 6 chance that we would get a 1 on our first roll. Now for the second roll, it's similar. 4 takes up only a single face on the die, and the other 5 spots are not the number 4. And so the probability that we would not get a 4 would be 5 out of 6. So that gives us a 5 out of 36 chance of satisfying both of these conditions. For probability B, we're looking at the case where we do not get a 1 and we do roll a 4 on our second roll. And so here, the probability we don't get a 1, and once again we're looking at an AND situation here, probability we don't get a 1 is 5 out of 6. Probability we roll a 4 on our second roll is 1 out of 6. So PB is also 5/36. And then for PC, we're also looking at an AND situation here. The probability that we roll a 1 is 1 out of 6, and the probability we roll a 4 is also 1 out of 6. So this one's 1/36. And so our overall probability that we either get a 1 first or 4 second would just be the sum of P, A, B, and C. So 5/36 plus 5/36 plus 1/36, and that gives us an 11 out of 36 chance that we satisfy either of these equations, or these conditions. Alright? And so this is how, if you're dealing with a multi-step process, how you could break it down in order to calculate the individual probabilities of each step, and that'll give you the overall probability.